Hey everyone, welcome back. This is lesson 8.1, variation functions. Your objective for today, you'll be able to solve problems involving direct, inverse, joint, and combined variation. Your vocabulary for today is direct variation, constant of variation, joint variation, inverse variation, and combined variation. In Chapter 2, you studied many types of linear functions. One special type of linear function is called direct variation. A direct variation is a relationship between two variables, x and y, that can be written in the form y equals kx, where k is not equal to 0. In this relationship, k is the constant of variation for the equation y equals kx, where y varies directly as x. A direct variation equation is a linear equation. All right, so make sure you know that, a linear equation in the form y equals mx plus b, but the only thing that's different about it is that the b is equal to 0. And the constant of variation, k, is the slope. So before we called it m for y equals mx plus b, and the m was our slope, but now we're going to call it k. It's the variation, it's the slope. Because b is equal to 0, the graph of a direct variation always passes through the origin. All right, so the very first example is of writing and graphing direct variation. First of all, we're given that y varies directly as x. All right, so when we see it saying y varies directly as x, what that means we're going to do is we're going to have an equation. It's going to look like y equals k times x. All right, and then the next information that they give us is that y equals 27 and x equals 6. So all we need to do there is to substitute 27 for y and 6 for x. All right, and once we do that, remember, we're going to always be doing first is solving for k. All right, so we're going to always solve for k. So in order to solve for k here, if we divide both sides by 6, then we can solve for k. So doing that, solve for the constant of variation k. And we get k equals 4.5. Now, we also need to write and graph the direct variation. So let's write the direct variation function first, and that is pretty simple. It's just y equals 4.5x. Okay, so on the next slide, we're going to actually graph that. So y equals 4.5x. Okay, so remember our equation was y equals 4.5x. So when we graph this, we could see that our y-intercept is 0 and 0, 0. So when x is 0, y is 0. And our slope right here is 4.5 over 1, basically. So it's rise 4.5, run 1. So there's our first point, and then so on. Rise 4.5, run 1. All right, so once we've done that, we can also check by substitution. We can fill in 27 for our y. So here's our equation, and here we know when y is 27, x we said was 6, so 4.5 times 6 actually is 27, and that is correct, so we know we did it correctly. All right, next. Here's a helpful hint for you. If k is positive in a direct variation, the value of y increases as the value of x increases. Okay, try one on your own real fast. Turn your video off and give it a try. All right, that one shouldn't have been too hard for you. The first thing it says is y varies directly as x. So that tells us that we're going to write the variation function, and it says y varies directly as x. So the way it would be written out is y equals kx. All right, and next we just need to substitute y equals 6.5 and x equals 13. So you can see that, and then we want to solve for our k. So we're going to divide both sides by 13. And when we do that, to solve for the constant of variation k, we get k equals 0.5. All right, so you can see now to write the variation function by using the value of k, we get y equals 0.5x. Okay, next we need to graph it. Again, our y-intercept is going to be 0 and the slope is 0.5. So our equation says y equals 0.5x. Actually, actually 0.5x. All right, so when we graph that out, it goes through our origin 0, 0, and when x is 0, y is 0, and then we're going to go over rise 1/2 over 1. So you can see our point here. All right, and here's all of our points. So we can also check it, all right, by substitution. We remember that our y was 6.5 and our x was 13, and when we multiply 0.5 times 13, we get 6.5 equals 6.5, and that is correct. When you want to find specific values in a direct variation problem, you can solve for k and then use substitution, or you can use this proportion derived that we're getting ready to see right now. So if we have y1 equals k times x1, we could rewrite that and solve for k and say divide both sides by x1 divided by x1. So we can say that k equals y1 over x1. And if we have another problem that says y2 equals kx2, again, we can divide both sides by x2, and we end up and we can say that k equals y2 over x2. Now, if k equals y1 over x1 and k equals y2 over x2, then we can just do some substitution and say, well, then y1 over x1 must equal y2 over x2. And that's going to look like a regular proportion that you're used to seeing. Okay, here's an example to do that very thing. The cost of an item in euros, E, varies directly as the cost of the item sold in dollars, D. And E equals 3.85 euros when D equals 5. Find D when E equals 10 euros. All right, so I'm going to show you two different ways to do it. The first method is we're just going to solve for K first. So what we're going to do is write E equals K times D, because it says E varies directly as the cost of the item of the dollars. So E, whenever you see the K, you say varies directly as the item in dollars. All right, so there's the first thing we have to do. And so we would substitute now what we know. We know that the cost of E is 0.85, and D is $5. So if we just substitute those in, multiply and solve for K, or divide and solve for K, we get 0.77 equals K. Now, once we know that, we can go ahead and write the variation function, which now says we're going to use 0.77 for K. So now we know E equals 0.77 times D. The euro equals 0.77 times the dollar. So the question says find D when E equals 10. So we're just going to substitute 10 for our E and have the 0.77 times the D. And now we just have to solve for D, our dollars, by dividing both sides by 0.77. And we get dollars is 12.99. Okay, same question, but this time we're going to solve it a different method using the proportions. And I like these proportions. Okay, so what I'm going to say is E1 is to D1 as E2 is to D2. All right, so we're going to use a proportion, and then I'm just going to substitute what I know. I know that E1 is 3.85 and D1 is 5. And I want to solve for when E equals 10. And so I'm just going to substitute all that. And then we can cross product. I know I use this, I call it the butterfly. We all do. Use our cross product. So we have 3.85 times D equals $50 or 50. And then you just have to solve for D by dividing both sides by 3.85, both sides. And when you do that, you end up with D equals 12.99. Either way you want to do it is going to work out fine. There's lots of different ways to solve math problems, and these are 2 ways that you could do it. All right, here's one for you to try on your own to see if you're understanding this type of problem. Turn your video off and give it a try and then come back on. All right, in this problem it says the perimeter of a regular dodecagon varies directly. So the first thing we want to do in this first method is just find k. So we're going to write our equation p equals ks. So p varies directly as the side length s. The next thing we want to do is go ahead and substitute. We see that p equals 18 and s equals 1.5, so we're going to substitute those in. Solve for k by dividing 1.5 on both sides, and we get k equals 12. Next, we need to write the variation function, and so we're going to use 12 for k instead this time, and we're going to say p equals 12s. Now the question says find s when p equals 75. So in place of p, we're going to substitute 75. And then we can just divide both sides because we need to solve. It says find s, so we're going to divide both sides by 12. And when we do that, we get the s equals 6.25 approximately. Okay, here's the second method you could have tried to use. Doing this one, we're going to use the proportion, and we see that the perimeter is to the side as the perimeter 2 is to the side. Substituting in with what we know, 18 is to 1.5 as 75 is to s. So here's our number. Our original is p equals 18. And our s, original side, is 1.5. They want to know what s is going to be when p is 75. What is s? Next, all we have to do is our cross multiplication. Find the cross products. And then we just have to solve for s by dividing both sides by 18. And now we have s. A joint variation is a relationship among 3 variables that can be written in the form y equals k times x times z, where k is the constant of variation again. All right. For the equation y equals k, x, and z, y varies jointly as x and z. Okay, so this is called a joint variation, and it's just kind of the same thing, but now we have added z variable in there also. So y varies jointly is how you would read that. The phrase y varies directly as x and y is directly proportional to x have the same meaning. So you could have also said that y is directly proportional. Okay, in this example, you're going to be solving joint variation problems. So the problem says the volume of a cone varies jointly. So let's just think about what that means. The first thing we want to do is we're going to find k. And if it says it varies jointly, we're going to say the volume varies jointly as the area of the base times the area of the height. All right, so next thing we're going to do is substitute the information that they've given us originally. They tell us volume, base, and height. The only thing they haven't told me is what k is. So I want to solve for k. So we're going to substitute all that in. This is 36 pi. I'm going to divide both sides by 36 pi so I can get k by itself. So I end up with 1/3. So we can see that k is going to equal 1/3. Once we know that, we're going to do the second step, and we're going to use the variation function again, which we saw, v equals k times bh. K varies jointly. So we're going to use 1/3 for our k. And my program didn't come out very well, but base times height times 1/3 is the volume. Next, we're going to substitute. Now, they told us what the new volume is and the new height, but we have to solve for b this time. So we already know our k. We're going to substitute in for our volume and our height. Multiply these together. 1/3 of 9 is 3, and then divide 3 by both sides. Let's see, divide both sides by 3. 1/3. 1/3, and 3 goes in that 8 times. So we see that when we solve for b, we get 8 pi equals b. So that tells us that the base is 8 pi feet squared. All right, here's one for you to try on your own. Turn your video off and see if you're understanding this okay. Okay, so this one again is going to be a varies jointly. The lateral surface area L of a cone varies jointly, okay, as the area of the base, radius R, and the slant height L. All right, so they're going to give us some information, all the information we need except for K. So the first thing we want to do is find K. So here's our variation function. And we're going to substitute all the information that we have. We see that L equals 63, R is 3.5, and the slant height, little l, is 18. Solving, multiplying and dividing and solving, we come up with pi equals k. So 3.5 times 18 happens to be 63, so those cancel out, and we just have pi equals k. All right, so now we have to use the variation function. So remember, the first thing we're going to do is go ahead and use pi in place of k, and they're going to give us all the other variables that we need except the one that we're supposed to find. So we're supposed to find r, so they're going to give us an L, and they're going to give us the little l. So filling everything in and solving for r, which is what they told us to solve for, we divide both sides by 5 pi, and we end up with, solving for r, we end up with r equals 1.6. Okay, a third type of variation describes a situation in which one quantity increases and the other decreases. For example, the table shows that the time needed to drive 600 miles decreases as speed increases. So you can see at 30 miles, it's going to take you 20 hours to drive 600 miles. But notice at 50 miles an hour, it's going to only take you 12 hours to drive the same distance. So as our speed increases, our time decreases. This type of variation is an inverse variation. An inverse variation is a relationship between two variables, x and y, that can be written in the form of y equals k over x, all right? And k cannot equal 0. And for the equation y equals k over x, we would say y varies inversely as x. So y varies inversely as x. That's how it would be read. Okay, so let's do an example involving the inverse variations. It says given y varies inversely now as x. So the first thing we want to do is notice that y varies inversely as x. So that's going to look like this. Y equals k over x. All right, now notice they're going to give me both y and x. So the first thing we have to do is solve for k. So we substitute y and x in 4 and 5 and then solve for k. And when we do that, we see that k equals 20. So we just multiply both sides by 5, and that leaves k by itself. All right, next is to just write the variation formula, and we just say y equals 20 over x because we knew that k equals 20, and so here is our variation formula. Okay, so we also need to be able to graph the inverse variations, and in order to do this, it's going to be a little bit different than we're used to doing. So first of all, we're going to make a table of values for both positive and negative values of x. So I'm going to use negative 2, 4, 6, and 8, and I'm also going to use positive 2, 4, 6, and 8. All right, so plotting the points, negative 2 is negative 10, negative 4, negative 5, right here. Negative 6 is negative 10 over 3, which is about 3 1/3. So that's there. And our negative 8 is about 2 1/2. So then you just connect your points. And then we're going to do the same thing where it's positive. So 2 over 2 up 4. Over 2 up 10. Over 4 up 5. Over 6 up 10/3, which again is about 3 1/2. And finally over 8, 5.5, or 5/2, which is 2.5. All right, so once you do that, you want to plot your points and connect them with two smooth curves. Okay, now remember, because division by 0 is undefined, the function is undefined when x equals 0. So if I were to put in x equals 0 here, I would have y equals 20 over 0, and that's undefined. And you notice our plot show that we're never going to get to the 0 on our x's or y's. All right, try this one on your own and see if you're understanding okay. Turn your video off and give it a try. Okay, so for this one, again, this is a varies inversely. So it says y varies inversely as x, and so the first thing we want to do is just write our equation out. Y varies inversely as x. And then the next thing we're going to do is just substitute. We already know what an x is. Y is 4 and x is 10. So what we have to do is substitute and then solve for k. And there we have it. And so by multiplying both sides by 10, we get k equals 40. All right, next we need to write the variation formula out, which is y equals 40 over x. All right, and again, we need to graph it. So once again, we're going to make two tables. We're going to use both positive, negative, and positive numbers. All right, and we're going to plot them and then make curves, two smooth curves. And once again, because division by 0 is undefined, the function is undefined when x equals 0. All right, so just like in direct variation, when you want to find specific values in an inverse variation problem, you can solve for k and then use substitution, or you can use the equation derived below. So here's the equation. So if I have y1 and it's inverse variation, that's going to equal k over x1. And if we solve for k, we're going to multiply x1 on both sides, so we'll have k, and I'll put my ones in there, equals x1, y1. And if I have y2, and it's also inverse, k over x2, again, if I solve for k, multiply both sides by x2, and I have, again, k equals x2, y2. Then what we can say, since k and k are equal to both of these, we can just substitute and say, okay, well, x1, y1 is equal to x2, y2. All right, here's an example to help us clarify this. It says the time t needed to complete a certain race varies inversely as the runner's average speed s. So the first thing we want to do is figure out what our k is going to be. So we're going to set up our equation t, and notice it varies inversely. So we have k divided by s because it says it varies inversely with the runner's average speed. If a runner with an average speed of 8.82, so our speed, miles per hour, competes the race in 2.97. So in order to solve for k, we're going to substitute those two numbers in there. Multiply both sides by 8.82 to solve for k. K is 26.1954. Once we know k, we can use that to solve the rest of our equation. So we're going to say t equals, in place of k, we're putting 26.1954 divided by s. All right, so in the new equation, it says, what is the average speed of a runner who completes the race in 3.5 hours? So that's our time, so we're going to substitute 3.5 for our hours. And when we do that, we will have to do some rearranging of our numbers because we need to multiply our s by both sides to get it out of the denominator, and then divide both sides by 3.5. And when we do, we end up solving and saying s equals 7.48. And notice that makes sense, okay? Always check to make sure that your answer makes sense. If our runner with an average speed of 8.82 competes it in 2 hours, you can see that this speed is a little bit lower. It takes a little bit longer, 3.5 hours. All right, so we have another method that we can use for for finding this inverse variation. And as I showed you just a minute ago, we can set up and use the method of T1 S1 equals T2 S2. All right, so once we have that, we can just fill in our blanks and substitute all the information that we have. So we have 3 parts, and the only thing that we don't have is our speed. And so now we can just solve for S, and we end up with the exact same thing. And so our S is equal to 7.48. So the average speed of a runner who completes the race in 3.5 hours is approximately 7.48 miles per hour. All right, turn your video off and try this one on your own and see if you can understand what you're doing. Okay, so it says the time it takes for a group of volunteers to construct a house varies inversely as the number of volunteers V. So the first thing we want to do is solve for K. All right, so we got to set up our equation. Since it's inverse, we're going to have K over V. All right, and next we want to do is just substitute. They gave us some information. We have 20 for our volunteers, and we have hours 62.5. So we're going to substitute those in and then solve for K. And once we have them substituted in, we can multiply both sides by 20, and we get K equals 1,250. Once we have that, we can use that 1,250, substitute it in for K, and then we look at our question some more. It says, how many hours would it take 15 volunteers? So 15 is less than 20, so we know it's going to be a little bit more than this 62. So if we put 15 in, substitute 15 in for our volunteers, and multiply, we don't even have to multiply, we already have T equals. So when we just put in the calculator and divide it out, we see that time equals 83 1/3 for our time, 83 1/3 hour. All right, so here's the other way that we could check it out, that we could have solved this. We're going to use this equation, T1V1 equals T2V2. So there's our equation. All we have to do is fill in all of our information that they gave us on the earlier page. And they gave us everything except for this very last T2. And so we just multiply and divide both sides, and we end up getting 1,250 equals 15T. Divide both sides by 15 to solve for T. And again, we get T equals 83 1/3. So the number of working hours it would take 15 volunteers to build a house is approximately 83 1/3. All right, you can use algebra to rewrite variation functions in terms of K. So if you take a look at it, if we have a direct variation, we see y equals K times X. And if we want to write it in terms of K, we're just going to solve for K. And so all we would have to do is divide both sides by X. And that's how we get our y over X. And it's a constant ratio. So whenever you have like this division, that tells us it's a ratio. All right, if we start out in the inverse variation and we want to solve for K, we're just going to have to multiply both sides by X. And we have XY. And this is called a constant product. It's where the constants are multiplied together. Notice that in direct variation, the ratio of the two quantities is constant. In inverse variation, the product of the two quantities is constant. All right, so they're both constant. This is just called the constant ratio. This would be a constant product. All right, in this example, we're asked to determine whether each data set represents a direct variation, an inverse variation, or neither. So let's take a look at letter A. All right, remember, we want to look at this, at these and see if they're either X times Y or Y over X. All right, is the ratio between the two. So when I look at 6.5 times 8, I don't really know that right offhand, but I do know 13 times 4 is 52. And when I put in my calculator 6.5 times 8 and 104 times 0.5, I do see that my x times y in each case is 52. So the product is constant, so this represents an inverse variation. All right, so when you have the product, it's actually the inverse variation. Now looking at B, when I look and see my y divided by x, so that would be 30 divided by 5 equals 6. 48 divided by 8, that's 6. And I know 72 divided by 12 is also equal to 6. So what that tells us, in each case, y divided by x is equal to 6. The ratio is constant, so this represents a direct variation. So you'll just need to kind of think about what you're doing. So if you have y equals kx and you divide x by both sides, that was originally a direct variation. So that is going to, when we look at it in the chart, it's going to look like y divided by x. All right, let's look at another sample. All right, one more example. Let's first test to see if it's an inverse variation. So an inverse variation will be x times y. X times 3 times 5 is 15. 6 times 14 is not 15, so I know it's not an inverse variation. Now I'll try a direct variation, so I'm going to say y over x, and 5 over 3 is actually equal to 1.6, and 14 over 6 equals 2.3, and so that doesn't match up, so I automatically know it's not a direct variation. So therefore, since x, y, and y divided by x are not constant, this is neither a direct variation nor an inverse variation. Try these next two on your own. Turn your video off and give it a try. All right, so on this one, the first thing that we want to do, I just take a look at 15 times 3, and I know that's 45, and I know 5 times 9 is 45, so I really just have to put in my calculator 3.75 times 12, and I happen to get 45. So that tells us that when I multiply them together, x times y, that's an inverse variation. So in each case, x times y equals 45. So the ratio is constant, so this represents an inverse variation. All right, so just because it seems logical to try, let's try y over x first. So we're going to say 0.2 divided by 1 equals 0.2, and 8 divided by 40 is 0.2, and I bet 5.2 divided by 26 is also 0.2. So that tells us that in each case, y divided by x equals 0.2. So the ratio is constant, so that tells us this is a direct variation. All right, a combined variation is a relationship that contains both the direct and inverse variation. Quantities that vary directly appear in the numerator, and quantities that vary inversely appear in the denominator. So let's see. Okay, this example is going to help us understand the combined variation. Let's see what else is going to happen. It says the change in temperature of an aluminum wire varies inversely. Okay, so the wire is going to, as its mass m, and directly as the amount of heat energy E transferred. All right, and it's going to tell us about temperature and everything. So let's go ahead and put these in. I'm going to turn the page. Okay, so the first thing we're going to do is take a look at this problem again. It says the change in temperature of an aluminum wire varies inversely. All right, so that tells us that the change in temperature is going to vary inversely. So we're going to have our K on the top as its mass. All right, and directly as the amount of energy. Okay, so it's going to be set up like this. So the first thing we want to do is solve for our K. Now you notice they're going to give us all the information that we need in order to find K. Okay, they're going to give, we have 4 variables and they're giving us 3, and we just have to solve the last one, which is k. So we're going to, here's our actual equation, and we're going to substitute all the points that we know and solve for k, and we see that k is going to equal 1/900. Now they're going to give us all the information that we need except for one thing to answer our question. It says how much heat energy, so we're going to be solving for E, but notice that they've given us transferred to aluminum wire with a mass. They've given us the mass, and they've given us the change in temperature. So let's go ahead and fill all the information in that we know. We're going to use 1/900 for K and set up our equation. And we know that our change in temperature is going to be 20. It says raises its temperature 20 degrees. So let's set it up. 20 equals E over 900 times 0.2. And when we do our algebra, we can solve for E and find out that the E is 3,600. So what that tells us is the amount of heat energy that must be transferred is 3,600 joules. All right, try this one on your own. Okay, I'm going to go ahead and change the slide and so we can have more room to work. I hope you were able to figure that out on your own, but let's go ahead and get going. All right, so the question says the volume of gas varies inversely as the pressure. So we're going to just write that down. We need to find K, so before we can do that, we're going to figure out what that means. So it says the volume varies inversely as the pressure, so that means K over P, and directly as the temperature, so times our time. So in order to find our K, first of all, we're going to set up our K equation. So the combined variation says V equals K times T over P. Next of all, they've given us all the information except for K. They're going to give us volume, pressure, and time. And so as we look in through here, we see volume is 10, temperature is 300, and pressure is 1.5. So we're going to just substitute all of those in. And when we solve for K, we find that K equals 0.05, 5/100ths. The next thing we want to do is use the variation function. So we're going to use 0.05 for K, and we're going to put it into our function. And then we need to substitute because they've given us new stuff now. They've given us that the gas is heated to 400 and has a pressure of 1 atm. So what is its volume? So we're going to substitute those two things into our equation, and notice it's asking for volume, so we already have it all set up with volume equals, multiplying that all out. Solving for V, we see that V equals 20. So the actual answer of your problem is the new volume will be about 20 liters. All right, that's the end of our lesson. If you'd like to turn your video off and do these on your own, you can. If you don't get them or understand them, we can do them again in class. So turn your video off. All right, and here are the answers for number 1 and the answers for number 2. And one more video, or one more slide, actually, one more practice problem for you to try on your own. And the answer to that one is 3.3 atms. So I hope you learned a great lesson today about variations, inverse and direct, and then the combined. And so that's the end of our lesson on K today. Hope you have a great day, and I'll see you soon. Bye.